getting mute. No, let's start with presentation. So, hello everybody. Thank you very much for coming to this event. We made it. It's nice to have everybody again together. I really hope we will have soon opportunity to meet in person. I will talk about regular expressions in SQL Server. This will be a little bit sarcastic overview of 20 years of development. I am Dejan Sarka. I'm pretty long in this business, near 35 years approximately, and even with SQL Server dealing from 1992, so also with SQL Server is approaching my 30 years of experience. I'm a data platform, server, MVP, MCT, authored, co-authored 18 books so far, etc. So what I will talk about is comparing 10 different solutions for regular expressions in SQL Server. Java, all kinds of T-SQL expressions, including full text search, C# or scalar, XQuery versions, R possibilities, and Python, and then make a conclusion. So first, I started to, let's say, explore Java support in SQL Server 2019. And the first thing I met was Microsoft Documents official tutorial, search for a string using regular expressions in Java. And I will just show you this page. So this is this page, right? Tutorial search for a string using hello. I hear some echo. Damir, can you also hear echo?
Yeah, we can hear echo. Somebody should be muted.
Yes, please. Okay, seems like it's better now. Okay. So this is this tutorial. So I went through this tutorial, and the first thing I noticed was this. I mean, this tutorial will teach you how to find 2 strings out of 3. This is all in accordance. Okay, again some big noise. Excuse me.
Igor Godan.
Okay, thank you. So first I noticed is that it's working on 3 rows. I mean, come on. We are talking about enterprise solutions, and then we are searching for a string in a table with 3 rows, right? And then I went to check the code. And look, this is where the Java code starts. And it goes on and on and on. And it simply never ends, okay? And then you shall have to compile and create a jar file. And then you come to SQL Server, create external language. Okay, I will use Windows version, so I will skip Linux. Create external libraries. And then set permissions, right? And then you can start calling Java class with sp execute external script procedure. And we are searching for 2 rows that contain word Java in that text column of the demo table. So first thing I was telling myself is something is wrong here. A lot of Java code to find 2 out of 3 rows with word Java, and please note that this could be also done with simple transact SQL like operator. Also the code is not nice. Not 2 parts, name reference, no semicolons used, and so on. So I said, okay, let me test it. So we are switching to the code. First, I will just show you, this is just copy paste. I'm not really a Java developer. This is just copy paste, pasted from this tutorial. And then I can switch to transact SQL. Right? I already created a database, enabled external script, so I will be able to execute JavaScript and also Python and R, and created this table. But on the top of it, I also created a little big table, which will have one text and one XML column. And then you see this was like 30 seconds. I already inserted 100,000 rows, and 20,000 rows out of them have the word Java in them. So let me warm the cache, just select star from the table. So what you see is here I have 100,000 rows, and I have one ID and one text column where somewhere is XXX, and here or there instead of XXX is also Java somewhere in between. And completely the same thing in XML, so very, very simple XML with string, and somewhere sometimes in 1/5 of the strings there is a word Java in them. Okay, so now let's start testing. So I will also create a table, and I will store test results in this table. I will talk about, I will store the language, what kind of indexes are used, which year was this kind of language or expression available, how many lines of code I needed to write it, and what was the time in milliseconds to execute this code. So now let's create external language and external libraries for Java, including the one that I created, SQL regex. And this is again copy of the Java code, so you have everything. I prefer to put everything in a single file. I will share this SQL file with you, and you have also Java code here, and you will also have Python and R code here. And now I will create a procedure that we'll call execute external script, exactly following the tutorial. And this procedure will call Java to find these strings that contain some words. So let's start with the small case, 2 rows out of 3 from the tutorial. Okay, works well. But the point is here also that besides the data cache, I want also procedure cache, so I also loaded all Java objects in memory, so the comparison is fair enough. And now I can execute Java in my on my 100,000 rows and search for those 20,000 rows with the expression Java in them, and measure also time elapsed, and I counted the number of rows manually all together. You can see here in the comments I have lines, how many I needed, so 99 lines just of Java code. And altogether, I needed 126 rows to get here. And let's execute. I'm searching for 20,000 rows out of 100,000. This doesn't look like something extremely hard for SQL Server. I have 4 cores, I have 16 gigs of memory in this virtual machine, and we are here. So elapsed time was 17, nearly 18 seconds. Okay, so this is Java. Now I remembered immediately that, you know, in 2005, the CLR was for the first time supported inside SQL Server, C# in VB and Visual Basic. And the first demos for C# and for VB were about regular expressions as well. There is a string utility sample in the documentation, and I also opened this link already. So this is then showing how to create function to test for regular expressions, also in C# and then later also in VB. Anyway, I created this myself. I don't like this C# code. I'm better in C# than in Java. I particularly don't know much about Java. So my code is shorter and more efficient than the one in the tutorial. Anyway, I also counted these lines. You can immediately see that the number of lines is much lower than the number of lines in Java. So let's go now to SQL Server, and this is again this copied code for C#, so I will need to share only one file. And I already enabled CLR and created the login. I signed the assembly, so I created the login based on this signature, created a symmetric key, and trusted assembly login. So this login will be able to execute, or my C# code will be executed in the context of this login. Now I will create or import the assembly and create the function. I added 14 lines of code here. Let's check. Remember, data cache is already warmed up, so let's also warm any CLR objects. So you see it's working, checking whether the mail is okay or not. And now it's time to check it on my big data set. And let's execute this. And okay, even without measuring the time, you can see that it was much, much faster. 1 second, so it was like 17, 18, 17 times faster. Wow, right? But we are not done yet. We are not done yet. Remember, in SQL 2005, we have also XML data type for the first time, and you can browse XML inside this type with XQuery language. In SQL Server, for this task to find a specific substring inside a string, we can use XQuery contains function. Please note that XQuery can also search for full regular expressions. It has inside XQuery definition the matches function. However, this function is not supported in transact SQL implementation of XQuery. Anyway, since the Microsoft documentation gives us demo with such a simple example, I will use just the contains function and have comparison also with XQuery. Before I go to code, what else? Remember then in transact SQL, we have like operator. Okay, it's not so powerful as regular expressions. However, in this case, can be used since, as I said, since the documentation is so simple, I can also use this simple operator. And by the way, it's much more powerful. You can search for much more advanced strings with it, though it's not full regular expressions implementation. In addition, since this is pure T-SQL, I can also optimize it easily with maybe covering non-clustered index, etc. And yes, it's with us at least from 1992. This is for the first time I remember it in SQL 4.2. However, I started this presentation, let's say, with SQL 2000 to have 20 years of development. If I would start with 1992, probably half of you were not even born at that time. And on the top of it, in SQL 2000, we also got full text search, good implementation. And full text search brings you contains predicate in the where clause, which works similarly to contains function in XQuery. Can also search for some simple patterns. And it uses special full text search indexing. So time to go to transact SQL, not C# code, right? And since the data is cached, I don't need to warm any procedure cache for a simple like operator. So I will just insert, execute the query and insert everything, including time. This time I'm using clustered index scan. I'm just searching where txt1 like Java. Let's execute this. And yes, you see immediately half a second. So 3 lines of code and 35 times faster than Java. Now let's try to optimize it. Let's create covering non-clustered index and warm the cache by selecting all data using this index. And then like operator with covering non-clustered index. There will not be much difference since the whole table has only one additional XML column, still should be a little bit faster. Okay, first time it was not, I should repeat this multiple times, but I will skip this repeating in this presentation. Anyway, with larger tables, the difference would be higher, I mean, in favor of covering non-clustered index. Now let's go to year 2005 again and search in this table. So I'm using now again the full table scan or clustered index scan. I will search in this XML column those rows where exist in a string exist method will return true when the string will have Java in it. So where XML1 exists, row contains Java equals 1. So let me execute this code. Again, you see, I just needed 3 lines of code also for XML, clustered index scan, and results comparable to like operator. However, we are not done yet with XQuery. We can also create XML indexes, specific indexes to optimize searches inside an XML column. So first you must have primary column that creates kind of tabular representation, so-called edge table of this XML. And then you have 3 different XML secondary indexes. One is for value. You can create index for path, for attribute, or for value. I'm searching for a value. So this should be optimal index for my XQuery. Let me now warm the cache. I will now also execute this with included actual execution plan just to check which kind of index it was used. However, I will not insert the data yet because I want to warm the cache as well, and creating execution plan also takes some time. So you see it was pretty fast, right? Execution plan, let's zoom to fit. So it was clustered index scan and it was index scan filter. So apparently it didn't even bother to use the actual XML value index. It used primary XML index. So even I could drop the XML value index. I would need to have longer strings to make XML secondary index for value useful. Anyway, everything is worked out. Let me exclude execution plan. I don't want to slow down this query. So execute everything with inserting into the results table less than half a second, 480 milliseconds, without even using secondary XML index for value. So this was up to this point by far the fastest solution. And still, once you have these indexes in place, the query is still only 3 lines of code. Okay, is this the best I can get? Let me also check full text search. So I already installed full text search. So you see server properties full text installed gives me results true. So full text catalog is a logical grouping of full text indexes, and I will create full text index on my txt1 column, language 1033, this is language ID, this is US English. And with change tracking auto, so we will use SQL Server change tracking feature to populate this index. Let's wait for a second or two. It's still not huge table, 100,000 rows, but the full text index population takes a couple of milliseconds or maybe a couple of seconds. Anyway, first let's warm the cache again, execute this with full text search, and this was even faster. And now, since the cache is warmed, could be even faster than previous time. And we came even below 400 milliseconds. And once you have indexes in place, I still use only 3 lines of code to get here, you see. So, pretty impressive. We are still not done with possibilities. There are more languages supported. Remember that SQL Server 2016 brought R. So for the first time, R was supported inside SQL Server. Well, R is an open source language, so it has many, many libraries, 13,000, 14,000 libraries. However, since the vast majority of these libraries was developed in academic environments, many of these libraries do not take much care about scalability, about performance. Many of them are single-threaded. In the past, there was a company called Revolution Analytics that was building scalable R library and building its own libraries with some of the most popular algorithms and functions in R rewritten in a scalable way, highly parallelized. So initially, for SQL 2016, Microsoft acquired this company together with the RevoScaleR library. Now we have also more additional libraries like Microsoft ML library. Still the same people are developing these libraries. However, now they are inside or covered with Microsoft umbrella. So from RevoScaleR, all functions, scalable functions, their name starts with Rx, like rxDataStep. And there is basic R grepl function that can help you searching for a regular expression. In R, you work with a structure which is called data frame. R doesn't work with tables. Data frame looks like a table, however, it is a matrix. So we still have positional access. On the top of data frame, there is a very popular library, data.table. So this is open source library. Gives you more like a relational approach. And it's also performing extremely well. So this library is becoming very, very popular lately. So let's check how it looks in R. And I will just go to RStudio and start with basic R. So I am using ODBC to connect to my SQL Server with I can use trusted connection, right? And now I will just read SQL Server data. So I'm reading this in an object called data frame. I can view this data frame. It looks like a table. It has two columns. However, it's not a table. Now I will just create a subset with subset function. So this is just core R without any additional library, grepl function. And I will search for Java expression in this txt1 column of my data frame and store this in a new data frame, RT with Java. And you can see that this was done like in a millisecond. It was extremely fast here in R. So what happens if I use this rxDataStep? So I must load the RevoScaleR library and create my own the function that will use grepl. So it will be highly parallelized version. It will search in parallel in multiple, since I have 4 cores in 4 threads, hopefully for the substring Java in my 6th column. And this was, you see, total chunk time was like 739 milliseconds, right? And I got this RT1, again, this 20,000 rows, 20,000 observations, where Java match equal true. I already installed in advanced package data table, so let me also load the data table library and create the data table object out of my data frame. And let's check this class, and you see data table is actually an expansion of data frame. So this object is still of type data frame, but also of type data table. Now, if you are focusing on R, you should try using data.table because it's much faster. However, R is not extremely consistent language, so there are many functions, algorithms that still do not accept data.table as input, although it's also data frame type. So sometimes you will have to revert back to data frame to to call some functions, right? So let's now use it. So this is for an example of just selecting a couple of rows. So I have this Java match is currently not applicable, and I will just use the grepl function inside my data table, right? And you see this was even faster. You couldn't even notice when it was already finished. And here it is again, the full result. I didn't even bother to update Java much. And the last thing I did is I already did this in advance. So I downloaded the package because in SQL Server, inside SQL Server, you cannot just use this command install package. It is too dangerous. Imagine that you would allow this command on your production SQL Server. So this command goes and search for our sites, then downloads the zip file, unzips it and install it in your R engine. A very nice way to get the virus. I guess Jasmina Zemovic would be very happy if you would do this. Anyway, so let's go to our SQL Server, and let me just show you something else. I have already opened one more application, the last one, SQL Server Configuration Manager. Maybe I will need it. Turns out that when you switch from language to language, sometimes this Launchpad service that is communicating with outer languages, outer engines, including R, Java, and Python, is not fast enough, and you have to restart it. Now, this R should work at this moment, since it was enough time passed since I actually used Java in SQL Server, and I will go only up to here to also warm up the connection and Launchpad service. If I will get an error, I will go to standard Microsoft resolving procedure, which means restarting something. Okay, 8 seconds. Okay, but it was just warming up. So let's execute it once again, and this time insert the results. So altogether, I needed 25 lines of code. I will show the code later. Let me just execute this. And while it is executing, here is my code. So sp execute external script is the procedure. And you see, it has parameters. First parameter is language. We already used it for Java, but I will describe it now. And then this is the actual script. So this is the actual script in our language. And you see what I'm doing here. I'm simply using RevoScaleR, rxDataStep function, and using my transform function with grepl system function to find all rows which include keyword Java. And I'm returning a data frame. So rxDataStep will return me a data frame. And input data is simply a query from my source table. Input data name, this sp execute external script system procedure will convert my results. So this is tabular results, relational results, will convert to a data frame which is seen as RT inside the R code. You see RT, I can refer to this data frame. And this is output RT1, which will be then converted to tabular format, and these are the result things. Now this was done, so I already inserted, right? Or didn't I? Let me check. You see, this is something that comes with age. Anyway, if I would execute it again, this one would be inserted twice. I just select what I've done. Yes, I already executed with insert. So I can still remember everything from 1992, but I don't remember what I executed 2 minutes ago. Anyway, time, it's not very flattering for highly scalable library, right? Not very flattering, not so slow as Java, but apparently this communication between SQL Server and DAR takes a huge price. Remember, this was like 10 times faster in R itself. And in SQL Server 2017, we have also support for the Python language. And Microsoft rewrote many of functions from RevoScaleR library to RevoScalePy library. So this is the Python version of the same library. Please note that not all functions were rewritten, so you have better support for R still in SQL Server 2019 than for Python. Anyway, rxDataStep is supported. However, I will not execute it again since we saw we were not really excited with our version. I will just use the regular pandas str.contains function. Pandas is the most popular data science library in Python. It brings the data frame object. So Python is in data science more or less following R. So let me first open the Python code and import some libraries. So NumPy brings basically matrix calculations, and then pandas brings the data frame object. So now I will connect with OWC driver to my SQL Server and read the data. And this is some demo data. You see shape 100,000 rows with 2 columns. These are the columns. And with str.contains function using regular expressions, it's really just one line of code here in Python. And I'm creating a new data frame. You see a new data frame, which has, in this case, 20,000 rows. And these are these last 5 rows, which include Java. So let me also close the connection and switch to T-SQL. And hopefully there was enough time in between. So again, let's warm up the connection with Python engine. Execute only up to here and see what happens. If we are lucky enough, this will be without an error. Okay, we are lucky enough. So the second time, let's execute it with inserting the actual result. And it was pretty fast, 1.5 seconds. What's left? Well, there is one more demo left. Remember that I already loaded data.table, open source library or package. So in SQL 2019, you can import it with create external library statement. And this is my zip file, and language is R. And you see that IntelliSense doesn't really recognize all of these new keywords yet in Management Studio. However, it is working. Now let's also warm the procedure cache for R. I'm kind of expecting an error at this moment because I just finished with Python. Let's see. This is not a good sign. This is not a good sign executing so long. Okay, but it came through. Anyway, now it's warmed up. So let's now go, and so also the launchpad has some time, needs some time to switch between Python DLL and RDLL. So now let's execute it with everything warmed up. And you see it was much faster than the first time. Okay, we are done. I searched for these things all together in 10 different ways. So first, let me show you the results without any specific order, like order how it came in the table. So I compared, you see, I compared Java, C#, T-SQL LIKE operator with clustered index scan, T-SQL LIKE with non-clustered covering, XQuery with clustered index, XML primary index with FTS-contains, right? And rxDataStep in our Python pandas and our data.table package. So let's sort that. I'm sorting this by the calendar year when the code was available and time I spent in milliseconds. So starting with the year 2000, I had full text search. I needed 3 lines of code, 367 milliseconds. With like, okay, I should start with 1992 or maybe even earlier, I don't remember earlier times of SQL Server than 1992. But anyway, 3 lines of code. Okay, covering scans should be, non-clustered covering in the scans should be even faster. XML with primary index was also very fast, even with clustered index scan was still reasonably fast. And C#, okay, not so fast, but the best of all non-transact SQL languages. rxDataTable, okay, this is very disappointing. rxDataStep, this should be much faster than rxDataTable. Python was surprisingly very fast. And now we come to this poor Java. I mean, this is like a bad joke. 126 lines of code and 70,837 milliseconds. Anyway, you will say I executed only once everything. I did my homework in advance. So I actually executed these things in a loop like hundreds times. And here are the average of the results in my Excel file. So you see, when everything was warmed up, I got like 110 milliseconds with full text search. So wow. And 3 lines of code. Like was faster, not much faster, with non-clustered covering index compared to clustered index. However, it was faster as I expected. Remember, if the table was wider, the difference will be bigger. XQuery, surprisingly fast, especially with index, even without index. C#, also very good. And Python was in general faster than R, which was kind of surprise because, I don't know, in my experience when I used Python, it was usually slower than R, but this time was really excelling compared to R. Also, we see very efficient in terms of line of code. Data table, still pretty efficient, not too many lines of code. rxDataStep, also not very flattering for Microsoft, super scalable library, and come on, nearly 5 seconds. And as I said, Java in 2019 is basically a joke. Basically a joke. No wonder they are showing the demo example with 3 lines only, so primitive example. Now, we needed 20 years to come from 3 lines to 126 lines, 42 times more, and from 110 seconds to 14 seconds and half, even more. This is like 135 times more, approximately. So in 20 years, this is this great progress. So altogether, if I would slowly concluding this session, I would say first, stay away from Java in SQL Server. This is a bad joke, this implementation. Now you would say, okay, what is then if I need regular expressions? Looks like C# is somehow still the most efficient, but it's not really completely supported anymore. Oh, yeah, also I need to mention these colors in the table. In Excel, there was a legend, so let me show you Excel. So yellow color means partial support for regular expressions. So full text search contains and transact SQL like, of course, do not support full regular expressions. Blue color means actually XQuery means full support, but not inside transact SQL. So XQuery language has matrix function, remember, so it supports fully regular expressions. All other, but not in transact SQL implementation. So all other languages, C#, of course, also VB, R, Python, and Java have full support for regular expressions. Anyway, should you use C#? It's again kind of deprecated already to use scalar inside SQL Server. So it seems like Microsoft is forcing less and less efficient solutions. And on the other hand, if you look like documentation, when CLR support came, the first big function to implement was a regular expression match, and also in Java. So if this regular expression match is so important, my question is, why doesn't Microsoft simply implement this in the like operator? And I'm more or less done with my ranting. You can also see that I'm the oldest around here from this session, since I'm the only one who is showing the negative approach, not the positive. I'm too old to get excited with new features. I'm experienced enough to test them first and get excited later if they are good. So any questions? We have 2-3 more minutes. Any questions?
Seems like nobody has questions.
Okay, since everything is clear, the last thing to say is we are still planning SQL Saturday in Ljubljana in December 12th. I definitely hope that we will be able to meet much earlier, maybe already in June in Zagreb or in Osijek at Coolant Days or any place else. Thank you very much for attending. I'm glad we managed to make this event online, and enjoy the last session, and please stay also for the raffle. Bye for now.
Thank you.
Thank you.
Thank you.